back to the good stuff. But now I'm all kind of thinking about summer vacation, traveling.
Yeah, let's just go jam, we don't need to.
Oh, don't even get me started. What about the middle of nowhere?
So you were thinking, you said the middle of nowhere, what if something is out there? I mean.
Oh, I have some pictures of wild animals too. If you're one of those people who's scared by wild animals and you might not want to go.
They have a nice hole.
Yes, I've also been.
You've been there?
Yeah.
And it's, for me, something that I might not expect from Texas down there, but it's just part of the terrain that you haven't seen it, you might not expect. I'm used to things on the west coast. I've been all up and down kind of volcanoes and rivers and mountains and things where it's green in Oregon, Washington, and it's beautiful, but that kind of terrain I haven't been to as much. It'd probably be something I would like as well. I just don't know. I can't commit to things. I really can't. It's hard for me to say yes to that. You're gonna do more than pick up rocks.
There's gonna be a bonfire and a keg somewhere.
We're not supposed to do that. I don't know what really goes on, but I'm gonna say that that is not going to happen.
It's not in the syllabus.
But you might want to talk to some students who went on the Colorado trip if you want to hear some stories about what might actually go on. Okay, plot your objectives. You have those with you. Lee finished up that first side of part 1 page. At the end last time, I was telling you a little bit maybe about the kinetic molecular theory, or just kind of what that was, but I'm not going to test you on that, so you can pretty much cross that off for the exam.
Which one?
Number 8. And then also on Pascal's principle, number 4. Let's go ahead and cross that one off also. Yeah. Everything else on there we've covered. That's up through that last homework. I'll put a new homework set up for what we start today. I think there's 12 or 13 problems on there. That will probably be the last homework assignment, but I might get to just a little bit next time that I don't have on there yet. So if I add any more, it would just be a few problems, not a whole bunch. There's not much more than what's on the homework right now. If that's extra credit, it might be. For those of you who are already at 100% on your homework, you can't go over 100, so
What?
that you can max out your homework score at 15% of your grade. So if you're at 100, then don't beg for any extra credit because it's not really going to get you anywhere. But if you're not at 100, then
So we have a test on Tuesday?
we have a test on next Thursday.
Is it, you're mixing the final test with the final?
Today is
So
Tuesday.
this next test is going to be in the final.
This is part of the final. Part of it's comprehensive. The Unit 6 part will be just like a regular Unit 6 test. It might be just a little bit shorter to kind of give time for the rest, but
Is the comprehensive part all multiple choice?
all except for maybe a free body diagram or two with that same format that we've been using. And then all except for maybe a question or two where I've given you ones, conceptual questions before on the exam where I ask you a question with a brief explanation but not very long, something like that where I might just say, answer this question and explain. Sometimes those are just a few words or a sentence at the most, so nothing more than that style there. Is it what?
I usually fail those.
All those questions? The short answer ones or the multiple choice ones?
Both.
Well, then you might be failing half of the last test, because the comprehensive part will be about half of the grade. It won't be half of the time, it should really not take you very long to do it, but it'll count for about half of the grade.
Do you get the comprehensive questions like after the mastery homework?
No, some might be, but they're not all going to be from there. There might be a couple that you've seen before, there might be something from an old test or from a mastering. Those are good places to study to kind of get comfortable with the style of questions. And I think that some of those questions might have prepared you for those same types of questions on the prior exams. That's what we'll see. On Tuesday, we'll have time to kind of go over some of those things. Bring your objectives. I'll probably maybe bring your old exams. I'll talk about some of those things then. I'll go over the objectives, and there may be times where I'll say certain topics definitely won't be on there. And I might tell you there'll definitely be things on vectors or free body diagrams or something, but I'll just kind of give you a rundown of some of the things that you might want to study or things to kind of practice on. for that test. So that'll come up on Tuesday. We probably won't have time to start that on Thursday, or even if we do, we might just finish early and then kind of wait on that until Tuesday. But we'll see how much time we have. And actually, now that I think about that, if we have some time on Thursday, then I will start talking about it a little bit, and I might even try to make time now that I think about that again. Because it'll give you some time to study over the weekend, or at least some more kind of heads up. I could wait to kind of review some of the Unit 6 things, like some of them at the end, I'll just kind of talk about it all again briefly. We can wait on that until following Tuesday. Okay, so we'll see. The comprehensive part right now has 23 questions that are of that multiple choice or short answer form. That is, 46 points. That and a free body diagram or two, another 5 points or so. It's gonna be in that range of about 50 points, and with about that number of questions, 20 some odd conceptual questions, and then at least one of those free body diagrams, maybe two, where you set up the equations just like we've been doing all semester. Remember those with the little boxes on those pages? You should all know, hopefully, how to do those and what I'm looking for in those still. Okay. On the part 2 page of this Unit 6, the one that says part 2 right there, do you have it? You don't have a part 2?
Yeah, but scratch wood.
Does anybody have part 2?
I do. Make sure you put like rather than COVID, because I flipped it and I both of you.
Guess I'm the only one.
Okay, I'll get you a copy of part 2. Well, James is done with class right now, because
That's
he
all right.
finished part 1.
See you later.
He doesn't have a part 2. Okay, well, I'll get you a copy later on. Number 10 here says define kilocalorie, that's a definition I'm gonna put up here right here at the beginning. And we'll kind of get all the way through 15 or so by the end of today. There won't be that much left to cover on Thursday. Okay, so let's start talking about heat. Heat is not the same thing as temperature. So heat is the name used to describe a type of energy transfer. So heat is the energy added to or removed from the total internal energy of an object due to temperature differences. So heat is energy, something in joules. It's not the same thing as temperature. It's related to temperature and temperature differences, but it is an energy, something in joules. Don't confuse the two. If something has a temperature, you can't say that it also has heat. Okay? Heat is the process of energy flowing from one thing to the other. It's a transfer of energy from one object to their surrounding room, or from the room maybe to an object. Those two aren't the same. I'm just going to put, we use a Q for the variable. That's a capital Q that we're going to use for heat. So Q is a form of heat energy in joules. And let me define that kilocalorie for you now. It's the amount of heat or energy needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. From 14.5 to 15.5 degrees Celsius. So the amount of heat, the amount of energy needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. The calories defined based on that kilogram of water and how much energy is needed to raise its temperature by 1 degree Celsius. You don't have to remember the 14.5 to 15.5. That's true, that's what it is, but you don't have to write that down if I ask you to define that. Just tell me basically what I've written down up here. Don't forget that it's 1 kilogram. Don't forget that it's water. You make sure you state those things. It's not just raising the temperature of something by 1 degree. It has to be 1 kilogram of water by 1 degree Celsius. And make sure you're clear on your wording. Don't say raise it to 1 degree Celsius. I mean, you're raising it by 1 degree Celsius. I'll be a little picky on the wording there if you're not clear about what it is and how much the temperature is going to change by. That's how we define the kilocalorie. Kilo just means 1,000 like we've seen before. One thing with notation, 1 calorie is equal to a kilocalorie, where this C is a capital C, different than a lowercase c like that. Try to make that nice and big so you can see it. Be very careful when you're reading that a capital C means a kilocalorie. Okay. So if you see it written with a capital calorie, and if you look on any of your food labels, if you have anything in here, a granola bar or something, all the calories that you read on your food calories are capital C's. These are always thousands of calories. So when you read and you think, okay, I'm eating 100 calories and I'm doing good, that's really 1,000. But it's okay because we're still measuring things based on food calories. But these are all based on the capital C, the 1,000 calories. When I write things down on the board or when I give you problems, I'm never going to use the distinction between a lowercase and an uppercase c just because it's easy to miss when you're reading it. When you're reading the book, though, be careful when you're doing problems. I think you might have one where you have to do something with that. And usually when it's talking about food, it's going to be a capital C, and that capital C is a kilocalorie. I will write either a calorie with a lowercase c or a kilocalorie. I'm not going to distinguish based on the 1,000 with the capital C. Okay? But just be aware of that when you're doing problems, because you might see that somewhere. So 1 calorie, where now that's a lowercase c, just a regular calorie, is equal to 4.186 joules. That's a conversion factor to go from calories to joules. These are both forms of energy, not the same kind of energy like mechanical energy that we talked about before, with energy of position or of motion, but it's still energy in joules, same kind of joules we've been thinking about before. Okay. You don't have to memorize that, it's just there for reference. You might need to use it if you're making conversions to go from calories into joules. We don't use calories that much. So most times you're going to want to keep things in joules, but again, know that definition and just be able to convert if I give you anything in calories.